We are here at the University of California, Riverside at our Center for Environmental Research and Technology. My name is Matthew Barth. I'm a faculty member in electrical and computer engineering, and I serve as the lead principal investigator in the CARNATIONS University Transportation Center program. With our connected and automated vehicle research, we really focus in on the navigation and making the navigation and the positioning of those systems as resilient as possible. Now, the best way to do that is we test these things in both real-world vehicles, such as this one here, as well as in simulation. And a lot of the simulation work that we can show really looks at these complex scenarios about how connected vehicles can interact with each other and where they know their actual position and future trajectories as part of the navigation solution. So we develop our applications first in simulation, and then a lot of those techniques and algorithms we then take to the cars, and we're able to do testing on the road itself. So after we get the algorithms in the vehicles, we go out to many different locations outside, things like doing tests in the parking lots, and then we can even go on to real roads. Here in Riverside, California, we have a very unique situation where we're partnering with the city of Riverside to do automated and connected vehicle experiments. We have one dedicated road, which we call the Innovation Corridor, which allows us to take our vehicles out there and communicate with the infrastructure, communicate with other vehicles, so that we can test to see how safe are our systems, how much does the traffic flow improve, and we can do that in a very safe and well-developed environment. So really, by having both the simulation side as well as the real-world side, we're able to lift both parts of that and make it work successfully. So the key part of CARNATIONS, again, is, inherently when people design these systems, they're very fragile, meaning that if the communication gets jammed, or if there's data loss, or things like if the positioning loses track of where it is, then that tends to be a problem and the whole system fails. So the whole idea of CARNATIONS is to make that more resilient, more robust, so that they don't have these type of failures. So to give you an idea of the projects that we're looking at, one would look at being able to detect when are these faults occurring. If sensors have a problem or if the communication has a problem, we need to be able to detect that and then remedy and move forward from there. We have a simulation platform. As I mentioned, we constantly develop that simulation, and we improve the fidelity of that in order to see how well they improve. And then, of course, it's testing in the real-world environment. So vehicles like this, not only do we take it out to our local roads, we also take it to different locations where maybe the global positioning system is being jammed or spoofed, and we want to see if our localization system can still work under those conditions. So again, CARNATIONS provides us the funding to really develop these new robust techniques, which will be a big benefit for traffic as a whole, and really make automated and connected vehicles progress here in the United States.